Okay, hello everyone, and welcome to our webinar today. My name's Dion Wiggins. I'm the co-founder and CTO of Omniscient Technologies. Welcome and thank you for joining us. We do appreciate everybody joining us today. I'm joined here in Bangkok today with Professor Philip Kuhn, who's on his way to a conference in Singapore and thought he would stop by, and we put together this webinar. I'm also pleased to have with us today, in a recording format that is, Dr. Joseph Sweeney. Joe is an industry analyst and research director, and also an advisor on the future of work with a advisory service called IBRS, Intelligent Business Research Services. So he'll be giving you his thoughts on some of the trends and things that he's seeing in the industry. And we'll be able to talk a little bit about some of those trends after he's had a few words with us in a moment. If you have any questions, please don't hesitate to ask. We'll do our best to answer them around the end of the presentation. It is a packed presentation with a lot of information and some live demos. So we'll be going through and doing demos midstream, and we'll be happy to answer any questions either during the webinar or on email afterwards. This is being recorded, so if you can't stay for the whole thing or you want to share with your colleagues, we would definitely invite you to do so. So with that, we're going to get started. First of all, I just want to very briefly introduce Language Studio, and I'll be presenting some of these features today. So Language Studio has machine translation in more than 600 language pairs, voice recognition in 50 languages, OCR in 210 languages. We do file conversions in more than 200 formats. We have more than 200 natural language processing tools. We have about 60 advanced media processing tools. And today we're announcing the upcoming release of our generative AI tools, which has support for over 400,000 models. And you can also fine tune and customize those models. Now, one of the big things that's a selling point for our platform is that it's self-hosted or private cloud. That means it runs within your own network. That means a lot of the data privacy and compliance issues are immediately addressed. Now, I'm not going to sell and pitch to you today on those kinds of things. I just wanted to introduce our platform and introduce also Language Studio generative AI tools, which are coming out. So these tools are a module within Language Studio. They're comparable in functionality with ChatGPT. They give you training on your own data in your own office without the data ever leaving your office. There's a range of interfaces, office integration, web user interface, APIs. It's even able to do things like crawling and mining. And of course, it's very secure and private. And you'll see a few demos of some of the pieces and functionality as we go through today's presentation. As we go through the content, we'll be looking at some of our historical things as well. So earlier this year in January, we plotted how we saw things moving using a technique that I learned when I was working for Gartner called the Gartner Hype Cycle. So we copied their concept and we plotted our own points. And a lot of these have held pretty well. I'm not going to go through them today, but I would encourage you to go back to our previous webinars and have a look. I think there's some very important trends and you'll see where things are moving. And now I'm just going to switch over to Joseph Sweeney, who's pre-recorded, and he's going to present a very short presentation on his thoughts on where we're heading with artificial intelligence.
Hi, my name is Dr. Joseph Sweeney. I am the Research Director and Advisor on the Future of Work with Intelligent Business Research Services. In my role, I've been tracking and actively involved in what we're now calling AI or generative AI for many, many years, decades in fact. And what's happening at the moment is a watershed moment. But it's not necessarily just because of, wow, we've got this new technology. It's because the cost of processing technology, the cost of processing the large data sets needed for AI to work effectively have come down to such a point that, bang, they become effectively able to be given away. So no wonder we're seeing this absolute explosion of AI companies. Now, there have been some folks who've been in the AI industry for many, many, many years. And they know that a lot of what is happening in the market at the moment is let's be polite, let's call it hype. I've got other words for it as well. And what these organizations are looking at is they're going, hang on a tick, all of these things, and there's all of this rush to build these AI models and get them deployed into organizations. A lot of mistakes are being made. There's a lot of things that are being overlooked. And at the heart of those is business risk. One of the more common questions that we've been facing in the last about 12 months since this all blew up is from boards saying, what are the new risks of AI? And the first wave of those came around, how do we stop information from leaking? And yes, if you're using public services, many of the AIs that are based on things like OpenAI and so forth have very interesting clauses in their usage rights that give them access to the information that your staff are putting into these AIs. And yes, they will use that. Bear in mind, at the very heart of a lot of these new big libraries, like OpenAI, the very heart of it is massive, massive intellectual property theft. Some people take hundreds to that comment, but a lot of the data that they have collected was collected without individual citizens saying, yes, I grant you access to use this for the generation of AI. I don't think many people are realizing it was happening. And I think that the penny's still going to drop on some of the legal cases that are going to fall out of this one. And then there are many cases of outright copyright theft. For example, some of the AIs have been trained or have harvested information from known copyright theft environments, piracy sites. So that is a secondary risk. So you've got the data leakage and you've got the behavior of these large AI companies that have been generating these models. And now you've got the next penny to drop on that, which would be global legislation and copyright. So you can see there's a perfect storm brewing here. The other risks, though, that organizations are now beginning to realize, and this is an interesting one, let's forget the quality of generation. Let's forget the fact that these things hallucinate and potentially give you legal liability down the line. It's actually the risk of you not giving these services to your staff. A lot of the discussions that we're now having with our clients is migrated behind, beyond that basic, what I call risk hygiene, into one of true workforce vision. The simple thing is, if you do not allow people to do a job in the most effective way, using tools that they can readily get access to, they're going to go off and do it anyway. They're just not going to tell you. And we saw this with the first wave and the second wave of shadow IT. We see it now with enterprise shadow IT, even with entire department heads going off and grabbing really large, powerful information systems like Salesforce and so forth, without telling anybody else what they're doing, just going and putting it onto a corporate credit card or a corporate account. And this is just going to continue. Human behavior is really predictable in this sense. If tools are available that makes someone more empowered, lets them do their job at a higher quality, in an easier way, people will go and use those tools. The risk is, going back to these earlier risks, that some of these tools have, on the market now, have extremely worrisome terms of use. And the behavior of these organizations historically suggests that they will use your data in ways that maybe is not best for you. So what do we do about this? Well, I think the first thing is to recognize that you can't hold back the tide. You absolutely have to give your organization, your staff, tools that are at least as good, if not better than, ideally better than, what they can grab through doing a quick search on Google Chrome extensions or a quick internet search. There are literally hundreds of these tools. They're dirt cheap. Many of them are based actually upon just API calls to OpenAI. Microsoft's response is really interesting because Microsoft is saying, no, don't use those tools, come to us. We've wrapped them all inside our 3.6 environment, and it's going to effectively almost double your cost of Office 365, but that's okay. You can trust us. All the information will remain inside your locked little Microsoft tenancy. True, but you still need to put a huge amount of effort into organizing your information, to curating your information and getting it ready for that environment. And even then, if you take a very close look at some of the new privacy clauses that Microsoft has rolled out, there are still some question marks. Personally, I think Microsoft will get those solved, at least for enterprise accounts, certainly not for the non-enterprise accounts, but there's still a lot of work to do in that space. And also the Copilot, it's not really a single set of products, it's this huge menagerie of products, is still fairly immature. So we're in this situation where we do need to be looking for a more holistic approach. There's a couple of ways that you can do it. There are some companies, for example, Dion's company here, I know, does a good job of wrapping a lot of different types of AI tools into one platform. There are others out there. The other approach is to try and build all of this yourself. So you're going to build a generative model, or at least grab an open source generative model and run it yourself. But that very quickly gets expensive, both in terms of having to actually implement it, maintain it, and so forth. It's that whole bespoke challenge. And it also means that you're very likely to very quickly run into a situation where the market has moved beyond you. Because if you think that ChatGPT interface is the future, you are completely and utterly wrong. The future of AI is going to look extremely different from what it is now. Not so much because of the underlying technology, although there are a few things to come, knowledge graphs in particular, but that's a discussion for another day. But how these AIs, how this generative and machine learning AI will get embedded and put into chains will look a lot like processes. AI will be embedded through all of your SaaS products. It will be embedded through all of your office productivity products. And if you have to try and build all those links for your own internal system, your staff are just going to gravitate. Again, they're going to race out to the next shiny toy on the internet. So you really do need to be thinking, how do you both give your staff an environment that is going to work for them, that is going to be at least as good, if not better than what they can get, while at the same time keeping up with all of the new modern embeddings of AI into all the rest of your technology ecosystem. It's going to be a very fun decade. I'm Dr. Joseph Sweeney. Thank you very much.
Okay, so that was Joe Sweeney. He's in Australia, which is very early hours of the morning right now, which is why he recorded his presentation. And he had some really interesting points, and we're going to explore those a little bit further. So we're in the infancy of artificial intelligence right now, but the speed that artificial intelligence is being adopted and reaching core levels of technology adoption has never been seen before. You know, the internet took quite a while. Smartphones took a little bit less. AI is just flying through the roof, and the trajectory is very clear. If you look at it from another perspective, PCs took 20 years to get 50% user penetration. The internet took 12 years. Mobile phones took 6 years. Generative AI, probably 3 years or less. It's literally halving each time for these major technological changes. And let me be very clear here. This is as important to business as the internet itself has been, as mobile phones have been. It is changing the way business and people operate. So let's look back at ChatGPT. What made it so attractive? It came in at 1 million users in 5 days, faster than anything in history. You know, the reality is that, like the mobile phone, it made things accessible to everyone. Your grandma can use a mobile phone to send a message or to even find a web page, right? Now your grandma can get online and do other interesting things. That's the level of ease. It took away the geekiness of it. It took away the technical aspects. You could just talk to it like your next door neighbor, or like you're talking to your grandma, quite literally. It was just easy to work with. And so it's shot through the roof. Now, it's actually jumping up everywhere. So in the first 5 months, you can see how quickly ChatGPT went up. Nearly 30 million users in 5 months. GPT-4 came along and it kept going. GPT-4 is so popular now that OpenAI has had to stop taking new customers that are paying for GPT-4 because they can't keep up with capacity. So they have to solve that first. The number of new applications using AI has gone through the roof. But let's be honest here, a lot of these applications, as Joe said, are just using things like ChatGPT and other commercial generalist AI tools behind the scenes. Then you've got things like Hugging Face. The number of models they have is more than 340,000 now. I think actually the other day it was closer to 360,000. So that's growing rapidly as well. And these models are available to anybody. But with that comes hype, and the hype is absolutely out of control. We're in exciting times. We're at the infancy. There's much more to come, but most people just don't understand what AI is doing, what it's capable of, and what it's not capable of. But we're in the era that I call we are an AI company era, where every company on the planet is claiming they're doing something with AI. They claim, oh, we've integrated ChatGPT behind the scenes. We bring you the latest AI tools. Do they really? Are they really building their own models? There's only a handful of rather large organizations building models from scratch. Now, that doesn't mean that people adapting models aren't AI companies. They are. And that's one of the things that we specialize in and help other companies to adapt models to their own needs. But the reality is that, as Joe said, many are just doing simple ChatGPT or similar API calls and saying they're an AI company. That's far from reality. Then there is information that's outdated and so-called experts. So I was on a rather interesting presentation this morning, just listening in it was all about, everything you need to know about AI. And I'd say at least 30 to 40% of the information was out of date already. And that presentation was very modern. And, the people that had done the research for it really were out of date in their own right. So, what can AI do today? Well, when it's integrated with workflows, it can do almost anything for your business that you can do with humans. It's a vast array of tasks all across the board. But, we get told what it can't do as well. It's outdated. It can't answer based on current facts. For example, who's the president of the Philippines? So I plugged into ChatGPT this morning, who's the president of the Philippines? Not only did it give me an answer, but it gave me a link to an authoritative source, because now ChatGPT, for some time actually, has been connected with the web. It connects with Microsoft Bing, and it can go and search and find this information out and integrate it. And by having access to information, it reduces the chances of hallucinating and making silly mistakes. It's not foolproof by any means, but it has access to real current information. And both Google and Microsoft and many others are plugging in connectors to more and more things to give it real data sources. Now, Joe mentioned Knowledge Graph and other sources, so those two help reduce hallucinations. So giving it information helps it get the facts. It's not creating information if it has facts to work with. When it hallucinates, it's usually because it doesn't have any information, but it's really keen and pleased to try and help you, so it makes things up anyway. Now, if you look at the media, there's a whole bunch of perspectives. The first one is AI will destroy humanity. Now, depending on the rumors and the stories, maybe that's what happened with the board of OpenAI recently. There was some rumors around that. AI tourists. Oh, look, it's so cute. It's so fun. Let me play. Right. Then you've got people with distraction problems. Oh, look, it's shiny. Oh, look, a squirrel. And they focus on it for a little while. And it's the latest shiny thing. And then they move on, or they just use it casually. But then you've got people who are actually starting to use it seriously. It's a personal assistant. It's there for personal productivity gains. And that's the biggest focus right now. And from that perspective, whether it's DALL-E with images, whether it's ChatGPT or Google Bard or the various other high-end commercial things where people have spent literally tens or hundreds of millions of dollars in some cases training models, this is where people are spending a lot of their time. It's personal productivity gains. And me personally, I just wrote a huge document of in excess of 150 pages a few weeks ago. And I actually used ChatGPT to help me. I put all my ideas down, gave it facts, and had it craft text for me. And I was able to do that in less than 4 days in a massive document. But where the biggest value is yet to really take off. And that is AI for enterprise processing. It's just beginning. So we're already seeing very visible but early productivity gains. So for example, cost per support interaction using human is $2.58 for one fintech company. It dropped down to 13 cents with AI. The response time, 45 minutes down to 1 minute. And customer satisfaction, 55% up to 69%. And this is real data. So, we're talking facts here. We're not talking just theoretical. These are real. AI is delivering incredible value. So 55% time saved for developers using GitHub Copilot. That's huge. And the developers here at Omniscient are using these kinds of tools to help them with code every day. And it really does work. 45% reduction in human answered customer support requests. Time saved from editing video on Runway. AI chat rated higher quality versus physicians' responses in some areas. All of these things are incredibly compelling. Then we look at adoption in the enterprise. Well, a lot of them say they're adopting for things like AI-powered features for existing products. And that's not too big a stretch. New AI products, there's so many, and some of them are rather silly, some of them are rather smart. Personalization and support is a big one. Most are still in the very, very early stages. Very few have actually fully adopted it and actually got it through to the end goals. But they're getting there. And, while Omniscient has been an AI company for a very long time, we too are building new products and enhancing our existing products to use AI more. Okay, it's enabling things that we couldn't even have dreamed of just a couple of years ago. If you look at ChatGPT, people thought that interest was dropping off, but the moment they started adding new features in, like audio, search plugins, image handling, all these kinds of things, suddenly all the activity went back up again. There was a wave of people who found it an exciting new toy. Then they realized, sorry, it can't cure world hunger. Oh, it's a terrible toy. I don't like it anymore. Right? Then they realize, well, if it can do these things, it's useful. And it's continuing to be useful. I find new ways to use these tools, both our own and things like ChatGPT, every day. And I've never ceased to be amazed. And this is when I'm working in this space. Now, it's not all about ChatGPT, of course. ChatGPT gets all the attention. It's the darling. And all the drama around, the recent firing of Sam Altman and others also makes it even more exciting and compelling. But there's many other models that have been released. There's open and closed models. There's specialized for a purpose models. But most importantly, there's foundation models. Now, foundation models come from organizations such as Meta, who have been providing some great models for people to build on with their Llama 2. But there's a whole range of other foundation models as well that you can find on places like Hugging Face and various other sources. Now, here's a really important point. Your job will not be replaced by AI. It's going to be replaced by people who use AI. Sit in your boss's seat. Would you want to hire the dumb, slow version or the fast-enabled version? Now, anyone can use AI. These tools are made friendly. That's what makes ChatGPT so compelling. But if you don't want to use them, somebody else will, and they will take your job. That's the bottom line. Now, that's from the human interaction side. But from the business interaction side, obviously, that's a different story. But certainly, human activities are greatly augmented by AI. Now, let's start looking at open source. And for that, I'm going to hand over to Philip.
Yeah, let me jump in here. So one important development is that these big tech companies invest a lot of money in building gigantic models. And it seems like it's very hard to compete with that, and they take over everything. But actually, the opposite seems to be happening, that a lot of these models get released, that research efforts in academia and other communities also rebuild these models on smaller scale more efficiently, and that is being used by everybody. So you don't have to be at Google or OpenAI you find these models, to deploy these models. You can do this with readily available open source tools and open source models. To give just one example here is, or a few examples, models like Stable Diffusion, which is an open source implementation, the Llama language model that was actually publicly released by Meta, and there's actually an updated version of that. And behind that, the very kind of prominent models, there's a whole collection of models that were built by, as I said, various research labs, large collaborations between people, and always also with a focus on making these more efficient and nimble to use. So, therefore, I think the whole drive behind innovation is going to be open source. So open source is the foundation for everything going forward. So there's a lot of openly available research. There's actually no big secrets about how these large language models get built. So whenever one of these research labs releases their model, they currently actually release a very, very detailed report, 50 pages, on how exactly they build it and what exactly design decisions they make. And none of them are often very surprising. And you read this report and you're familiar with the technology, it's like, yeah, okay, they do the obvious thing. And here's a nice, interesting tweak. And here's a nice, different way of handling data. There's also an open community. Code has been available for now well over a decade on GitHub, where people share code, and the new development is Hugging Face, which also shares models. We actually host some solutions, and all that is open to everybody and free of charge. And there is open models and open data. So for instance, the large text corpus that most people use to build large language model is derived from Common Crawl, which is publicly available. You can access the data and use it yourself. And it's not just the raw data, it's also kind of this refinement data of instruction sets and so on. So yeah, basically, if you just follow how Linux, Apache, and our own Moses machine translation toolkit have kind of become dominant in the industry over time. Like all the big compute servers run Linux, which is an open source operating system. You can see the same thing mirrored now in the machine learning community. So there's machine learning toolkits like PyTorch, TensorFlow, everything available on Hugging Face. If this is all shared with a large community, all kinds of people will find efficiencies and improvement. And the current large language model technology is pretty much open source. The code that is used to train these models is open source, and to a large degree, even the data that is trained on. So here you see some diagram of comparing how well the kind of state-of-the-art GPT-4 compares to other models that are closed source, but also then all these open source models that you can have readily access to. So this is a human judgment on various performance tasks.
So now we have a problem though. Data privacy, data security, and compliance, regulations such as GDPR are really a notable thing. And some governments came along, they've since changed their minds and adapted. Things like Italy banned ChatGPT when it first came out. Other countries were considering similar, but regulations are beginning to come in, and they will come in and start locking things down. That's good for the industry, good for everybody, but it's sort of chasing the tail of a horse that's already left the gate. So it's a little bit hard to put things back in the box once they're out. Now, here's a good example of bad use of private information. So this company, Berrycast, as an example, allows you to work with meetings and things like that and transcribe them and do things. So it doesn't tell you, but it sends your data to Amazon Transcribe. And then it sends your data to ChatGPT and it summarizes it. Now, first of all, they don't have permission to share your data with anybody else. There's no disclosure that they're sharing your data with anybody else. And then if you're in Europe, it's transmitting to a third country, which is in breach of GDPR. So all around pretty bad. Now, just to be clear on that, ChatGPT servers, they only exist in the US right now. Now, I understand, or I believe, that they're actually very soon deploying some European servers, but currently, as I understand it, they don't have any servers in the European Union. So you can't transfer that data to a third country without violating. Now, if you get caught doing these things, it can be a $20 million fine or 4% of your firm's worldwide revenue, whichever is the higher amount, which can be very, very significant. So you need to look at protecting your data at all times. Also, the models themselves fail to meet the requirements that have been set forth by the EU AI Act. So you can see here there's issues with data sources, compute, energy, capabilities and limitations, risk and mitigations, and every single one of them is in breach of copyright. So, there's significant issues just with the models themselves and how they're created. And as Joe mentioned, interesting terms of use. So Google Translate, Microsoft Translate, OpenAI, they all have the same thing. Basically, if you're using their public services, you are the product, you're giving your data to them. You're not getting it for free at all. You're paying with your data. They take your data, they take rights to your data, and they can do anything, including sell it to anyone they wish. So just be wary there. And API use, where you're paying for it, is better, but it's still not that much better. There are inherent risks there as well. So can you do this in private? Well, Language Studio gives you the means to do all of these things in private. It gives you a very friendly user portal, and it gives you a whole range of APIs that you can connect in. And I'll be demoing some of these features a little bit later just to show you how they work. Now, these work 100% on-prem. That means self-hosted, either on your own hardware or your own private cloud, such as AWS, Google Cloud, or Azure. It comes with a series of APIs, so hundreds of APIs, in fact, so that you can connect all your applications into it. And of course, it's also going the other way, calling out to different APIs and different systems as well. Now, how do you navigate this? Let's start looking at how to navigate AI and LLMs overall. So let's start with a chatbot for support. So you need to do support for your company. You want to reduce things and get some of the benefits that you saw earlier in some of the actual factual use cases. So here's an example where you can see you teach it information. So for example, feed it your corporate URL and it crawls your website, or upload files. So it automatically will mine the content, download all your website and train it. And then just this tiny little block of code can enable the chatbot that you're seeing on the right-hand side here. Now, that's pretty basic, but let's just jump out and go and have a look at that just for a moment. So I'm just going to go over here. Here's the actual chatbot running, and I can say, tell me about Philip Kuhn and his work with the Omniscient Technologies team. Now, this is real time. It's been trained off our website, plus a little bit of other data that we have in-house, such as some of our former presentations and things like that. And here you can see a nice example. Okay, so it's really that simple. It just drops straight in. Now, I'll come back and show you a few more demos later on, but these are the kinds of things, when you feed it data, it can learn and understand and present results to you straight away. So that was our chatbot. Now, I mentioned APIs. It's the extra P that's missing. Okay, there's a fixation just on AI. Now, APIs go two directions. You can call APIs. So you can call, for example, the chatbot that we just showed, or the AI tools and workflows can call out to APIs to collect information. Now, it could be as simple as a Google search, or it could be connecting to one of your databases. It could be calling a REST API, and it's feeding information in. So don't get hooked up just on the AI. Focus on the API, where you're bringing data multiple directions and tying it together. Okay, that's how AI works best. It's not about it being creative for you. It's about it understanding your information and handling the information that's presented well. So imagine a chatbot where you're on a chat or a call with a customer and it says, oh, I made a booking last week and things went wrong. And I called up and your people said they would handle things. Now imagine if the chatbot could actually go and look at all the history of that user and say, oh yes, we did too. And it shows over here that we sent you a check or a refund, and here's all the information. It was sent on this date without ever involving a human. So it's answered the question or interpreted the issue from the user. It's then gone out, looked up the information, said it was definitely done, here's the details, and the user goes away happy, knowing that the check is in the mail or something similar. Okay, now APIs, it's all about bricks and Lego. Okay, with Lego, I build a house, you build a house, Philip builds a house, every house will be different. You have your own unique business needs. We can assemble all of these Lego blocks to do different things. And that's what our technology is all built around, is Lego blocks. Okay. Now, Joe mentioned this in his part. Enterprises must provide tools or they will lose control of their data. Why? Because the users are going to go out and find tools anyway. They'll either download it or they'll just copy and paste and share your data into insecure environments. They're going to find them, they're going to use them. So either you provide it or you're going to lose control. It's absolutely critical. So before we go into any more demos and some of the technology and things, just important to understand some of the foundational elements. So prompts and chains are very, very important. So I'm sure most of you have used ChatGPT by now, and you type something in like, tell me this or tell me that, like I just did now, or refine this or write this for me, and that generates something. Now you can do that from a template and just fill in gaps, and you can save templates. It goes to the LLM and it returns. Those are called components from a technical perspective, and when you bring them together, they're called a chain. Now we take these chains and we can make them very comprehensive. So we start off with a template, and that makes sure we get the information that we need coming in. Okay. We then have example selectors, and we have output parsers that can pass it on to another chain or another step. So we have things like I just did called Zero Shot, which says do this for me, and it gives me an answer. I can have a memory, the one I described about the customer who came in last week, and it also remembers the conversation plus looking up the database. Questions and reasoning, intermediary questions and answers, step by step through a chain. It can execute, it can react to answers and responses and carry on. And it can get more and more complex, deeper and deeper, depending on your user requirements and your business use case. So it's a very, very powerful set of features when it's done right with workflows. Now, let's take this to the next level. Let's do some basic document analysis. So one or more documents, and we can do things like text summarization. These are all the things you've seen in ChatGPT. So there's nothing special here, except when you start to go a bit further, when you're going multiple documents, document clustering, trend analysis of your own information, right? Data extraction, all of these things, all pretty basic as a concept. But when you're loading, let's say 100 documents, that's something ChatGPT can't do. But if it's running in your own office, you can actually do these kinds of things. Now, how do you be better than ChatGPT? ChatGPT, after all, we just saw on the charts, is the best today. Well, ChatGPT may be the best at being a generalist, right? But imagine what these things could do if they were trained on private data. Biotech with personalized medicine, media like Netflix generate shows on demand for you. 3D models from Autodesk that could generate anything you asked it to do. We've already seen some amazing things from Adobe with their generative AI things in Adobe Illustrator. Infinite worlds and content in Nintendo gaming. E-commerce, right? Your own personal concierge. So this is where the generalist versus specialist comes in. So we saw, for example, that Llama 2 is not as good as ChatGPT 4. So how could we make Llama 2 beat ChatGPT 4? Well, what we do is we take that general AI model, and it's broad in scope and shallow in depth, and we teach it vertical skills. Now, let's just use translation as an example. And Philip is a native German speaker, and he also speaks English. Now, he's very fluent, as you're probably aware, but I'm sure that if I asked him to translate an English technical medical article on neurosurgery into German, he would probably have a very hard time, right? Now, you don't know anything about neurosurgery, do you, Philip?
Not really.
Not really, right? So you would hire in the real world an expert who knows that domain, who can then translate it. So by teaching the machine a vertical expertise like neurosurgery, now the machine can fill in that expert role, and it will beat something like ChatGPT because it doesn't have the expertise either at the depth that's needed. And then you can teach it another skill, another topic, and you can keep going. And this is your corporate data. So you can start teaching it things automatically from your corporate data, and it can keep learning every single day. Now let's go one step further. This gets pretty heavy now. Let's take fraud investigation. Let's say it's a government department and they're investigating fraud and they're digging in. Okay, so first of all, they go on a raid and they raid 3 different locations simultaneously, investigating this fraud, and they seize a whole lot of computers and hard drives. So we have 3 hard drives from the first location, 6 hard drives from the second one, and another 3 from the third one. Now, we want these kept in what we call compartments. We don't want the hard drive from number 4 impacting the analysis of content on the hard drive in number 2. But we may want to, at some point, cross over and share information and link information and things like that. So this is very important. Then we go into things like inventory. So we start with the hard drive and we analyze it. And we find all the files on the disk, top to bottom. Anything that's there, we expand. So if there's a zip file or a PST file with mail, we expand that out into individual files. And we run basic language ID over it. Now, this is something that Language Studio can do today, right out of the box. It can pick these things up. Then we start digging a little bit deeper. So we prioritize processing. So the customer has rules that say anything in French, process that first, German second, and then all the other languages together. Okay, so if it finds any images, it detects, is it a document? Convert it to Microsoft Word. Do we have recordings of meetings? Transcribe them. Automatic language ID, automatic speaker ID, then detailed language ID. Is there multiple languages in a document? Object detection. Can I see things that are interesting? Is there a box of documents in the corner of this photo? Are there people that I'm interested in this photo? Then translate everything in this case to English. Okay. Base document classification, invoices, emails, contracts, what are they? And basic metadata extraction like people, addresses, dates, amounts. Then file metadata. When was it created, modified? And maybe that by this stage, you can already start doing some pretty advanced keyword searches. Then we go a little bit deeper and we start doing actual analysis with AI. So identify the list of frequently occurring terms, cross-reference documents that contain a list of names, right? Summarize large volumes of text so I can decide whether I even want to read this document. Group similar documents together to facilitate easier review. Then we can keep going. So we can now train custom classifiers. So if this was financial fraud for customs, tax, excise, that sort of thing, you know, analyze the transaction records, the shipping manifest, the tax filings, the customs declarations, link all of these things together. What are the red flags? Is there case references that I can refer to when I'm looking to prosecute somebody because I found something? Can you find any violations of this country's tax laws? go and just analyze all the data against each law to look for possible problems. These are the kinds of things it can do. Then you can come back and start prompting as a user and ask all sorts of questions. Like number 5 here on the bottom, highlight any discrepancies between the declared income and the income records found on the drive. So the tax department knows how much you've declared, so it can pull that up out of its database and match it against what you have on the hard drive and say, haha, I got you, or no, this is okay, this is clean. So all that information is sitting there and it can be mined with today relative ease from just 2 years ago. So let's go and have a look at some of these tools, shall we? So I'm going to go over to my Language Studio platform now, and I'm going to jump in here. So this is the login screen for Language Studio, and you can see it can connect to secure things like ADFS or various other authentication systems, but I'm just going to log straight in here. And the first thing I'm going to go to is our generative AI tools. Okay, so let me just give ourselves a little bit more space here. So here I can just ask a question. Tell me about Philip Kuhn. Well, let's just say, who is Philip Kuhn? Okay. And it's going to think about it for a moment, and it's going to come back and give me a nice little answer. Now, that's all interesting and nice and everything, but I want to go a bit more advanced. So let's go over to data sources. Now here you'll see the compartments that I had on the earlier slide pre-configured. And you see this hard drive came from reception front desk. Okay, now I've got the entire hard drive here visible and available to me. Now I can go here and set up compartments and I can say what's in them. And you can see that this is dummy data right now for this demo. But we loaded up, knowledge graph we trained, a vector database we trained, language model we trained. So now it can actually start asking and answering questions around it. We can load in files, we can load in text, we can load in a website. So here's the Omniscient website, download it and teach me about it. Now currently it's processing and bringing it in. We can have questions and answers, glossary, translations, all these kinds of things. Now, if we go back here, you'll notice also there's mounts. So we can actually mount to external data sources, let's say an S3 bucket or something like that. So that's compartments, and each compartment can be seen separately. Now, if I go back to my chat, and you'll see a data sources tab. So over here, I can now say, use all of these language models, all of these vector databases, and all of these knowledge graphs, or just some of them. Don't use these ones, only use these. So I can decide what data is actually being used to make this smarter. Okay. Now, if we go over here to prompts, you can see there's a prompt library and you can search for prompts and you can pop things up. So if I go to here, well, let's just add a prompt, nice and simple. So I can put a happy image. I can actually have it generate an image as well. I can make it public to share with my colleagues. Down here, I can give it a name, some tags, different categories that I can set up. Then I can say roles, task descriptions, the context, the specific environment, and this will run like a mail merge. So when I feed data in, it can mail merge for me the information. Now this isn't a very big box, so we can just go here and give it a bigger box to work with, and then we can close it down again. Okay, so once we set up our prompts, we can run these, and we don't have to repeat, you are an editor, you are doing these kinds of things. Okay, and we've got public prompts that are shared by other people or by myself and my favorites. Then over here we have workflows, and workflows get very interesting. So here you can see there's information, different kinds of workflows, automated report generation, business risk assessment. We're starting to get into some pretty powerful things here. Now, if I go here and I don't know what this one is, I'm just going to open it when it's ready. It's still loading, I think. Just give it one moment. So I can go here and add a workflow. Hopefully that'll come up. Okay, here we go. So here I have a very complex set of workflows, complex information, and we've got a range of workflows all the way through. So if I go over to customer service chatbot, and this one doesn't actually have any content yet. So let's start by bringing in Amazon Bedrock, Anthropic, any one of these tools, including your own model that you've customized with our training. So I can bring in ChatGPT and just bring it straight here. Which GPT do you want to use? Version 4, put in my keys, start running. I can connect that with embeddings, loaders, pre-built chains, pre-built prompts, output parsers. So here's my response schema, and I want to structure my response. I can go down here and I can do vector stores, so Chroma, Feist, various others. So I can bring in a Feist vector store. Okay, and I can connect all the pieces together. Okay, I can bring in utilities that let me do a Bing search, a post request, one of the SERP APIs, bring back some Wikipedia content, Wolfram Alpha, all of these kinds of things. Wrappers for my SQL database, I'll hook that in as well, and I can literally just start dragging and dropping pieces and connecting them and making workflow tie together. Now, I won't go through all of these today. There's too much information here, but there's retrieval tools, text splitters, different toolkits for JSON, OpenAI, tools for calculation, search run, podcast APIs, importer formats, all sorts of things. Okay, really, really powerful, and you can build connectors and workflows for pretty much anything you want. When you say generate over here, it generates Python code that becomes a REST API instantly, and you can then call that code. Okay, so that's the power of these kinds of things here. Now, if we go back over here, you'll start to see where they live. So here's my prompts. So here's my last 8 prompts. Here's my favorites, or I can go and search for prompts and run them. So here, let me just start a new chat. I might do a chat for, let's say, competitor analysis tool. And I'm using that workflow that hooks into my back end and does all those complex processes that I just drew. But let's go a bit further. So let's go over here and I can upload a bunch of files. And I can say, analyze these files on the fly. Tell me about this PDF. Now, I uploaded this file a little bit earlier, but I can just drag and drop. Now, I can upload 10 files. These don't go into the training data. These are for answering questions right now. Okay, well, let's go a little bit further. Let's go to speech recognition. And we'll go one step further there. We'll even do live translation. So here I've got speech recognition with transcription. And I'm going to give you a live demo of how powerful this can be. Now, I don't have this automated fully. I've deliberately chosen not to at the moment. So I'll click when I'm ready to send data, but I'll show you how this works. Now, this will just take a few seconds to initialize the speech recognition, and you'll see what happens here. Okay, good evening. It's evening for me because I'm here in Bangkok with Philip, and we're presenting today with live real-time translation. So the translation has a latency of 50 milliseconds behind the actual presentation. So as soon as a sentence is finished, it finishes. Now, AI is being used throughout this. So you can see here that AI is being used for the speech, and it's able to get context. So for example, if I say something that has the same sound but 2 different meanings, it will work out the context. That's what you see in the gray text before it goes black. So if I say, I put on a tie to go and meet my Thai friend for lunch, and you will see the spelling of this word here change in just a moment to the correct spelling based on the context. So that's AI learning the context around it. Now, what if this was a business situation? So I'm sitting here talking about my board meeting, and I can say, I don't know what we talked about last time, I can't quite remember, but I remember there was some important action items in the minutes of the last board meeting. Now, if I say send and submit, and here's JSON data, and you can see it here. Now, I've got to get at the right question. So I'd like to know about the last board meeting minutes. Is it going to help me or not? Let's see. There we go. And right there, it's just found my board meeting minutes. Okay, so here you can see we discussed, this is actually real, the Omniscient meeting where we talked about release plans for our generative AI tools. It hooked that in real time while I'm talking, and I could be having a meeting, talking with people, and it's brought up the action items. I could then say summarize it and do various other elements all in real time. Okay, so these are the kinds of things that these tools can do. Okay, so I'm just going to end the transcription. Now, you would have noticed over here I had a whole lot of other options, so it can generate data files for me of everything that was spoken, draft dialogues that can be proofread. It can create a Microsoft Word document based on my template, subtitles and captions, and it can even output them in formats like Disney or Netflix and things like that. Or just simple transcription text that can then go as the minutes of this meeting today. So those are the kinds of things that these tools can do. So I'm going to go back to the slides now so we can keep moving. And I'm going to pass over to Philip to talk about speech.
Yeah, so one exciting development that's happening over the last years is that these technologies that used to be quite distinct, like text processing, speech processing, image processing, all have been merging because they all use the same kind of deep learning architectures and methods, and they all have a lot of things in common. So I'm going to dive a little bit deeper here in the broad topic of audio processing and all the different tasks that evolve around audio and text. So there's text and speech, where you generate spoken content from text content, speech recognition, as Dion just demonstrated, speech-to-speech technologies, such as speech-to-speech translation, and things like voice cloning, that you want to have maybe speech translation, also speaking in your voice and your emotional state, and so on, and stem extraction, which Dion will demo in a little bit. So let me talk about speech translation in a bit more detail. So the basic idea is that you want to talk in your language and it comes out in the voice of another language. So that has become more and more possible due to advances in speech recognition, machine translation, and speech synthesis. Interestingly, all of these use very similar technologies. They all use sequence-to-sequence models, especially the transformer models. So you can both see text as a sequence of words and speech as a sequence of sound. So they're very similar in what they have to process. There is a lot of investment by big IT companies in this field. So Google released something called AudioPalm earlier this year. Meta currently has a big effort called Seamless for MT, and also foundation models for speech. There's Whisper that OpenAI released about a year ago, and also Microsoft and various other companies play on basically big speech models that do the same thing for speech as ChatGPT has been doing for text. Okay, so speech translation has been around for a long time. We worked on this already 20, 30 years ago, and usually we worked on it by just basically breaking down the process into these major components. So there's speech recognition, where you take the input audio and convert it into the text in the input language. Then you have machine translation that generates text in the output language, and ultimately then speech synthesis. So the trend now is to build, instead of this cascade of different models, an end-to-end speech translation model. So basically, there's a bunch of challenges with that, especially if you generate speech. How do you evaluate not just that it has the right content, but also that it has the right sound and audio quality and naturalness? That often involves in human judgment. So these are not always very easy to evaluate. One interesting tweak on that is also that you want to do simultaneous translation. So while the sentence is being spoken, we already want to start with the speech recognition and the translation, and the speech synthesis. So there's minimal delay between what is said in one language and what is translated into the other language. So there are various technologies for that. So methods here, the standard technology is to just wait for a few words and then start producing. That makes a lot of sense for text because the output should have a more similar number of words than the source. But it is less clear in speech because people might speak slower or faster, and the generation has to basically then mirror that speed in some degree. One big problem why there hasn't been a full-scale movement towards end-to-end speech translation is there's very little training data actually that pairs speech in one language and the translation of that spoken content in spoken form in another language. So there's very little data for this end-to-end task. There is a lot of data comparably for text-to-text translation. This is definitely the information richest modality. There's quite some data on transcription, naturally occurring, prepared specifically to train MT system, and the same data can also be used for doing synthesis, although there you're actually also very concerned about the voices that are being generated. So one solution to that is to just synthesize this end-to-end data. So if you have parallel text, synthesize the audio on the source and the target. If you have transcribed speech, write the machine translation and synthesize the output. So you can see you can basically create end-to-end data from these different individual data sources that only cover part of the way. Another solution is to build on pre-trained component. So you first build the pre-trained components. Let's say you build a really good machine translation system that does text-to-text translation, and then you're going to refine that by enabling it to also handle speech input in addition to text input, and then you do the same thing on the output side, where you refine it that it also generates audio instead of just the audio text. And then after you have all this then integrated and set up, you can also do end-to-end training to actually do fine-tuning on the task where you preserve the speech information and generate speech information as rich as possible. So here's an example for that. This is AudioPalm from earlier this year from Google, where they started out with a text language model, Palm, and they basically said, well, we have a text language model. Let's just make it also possible to process speech and generate speech. So it had to also then take the speech input, which has to be encoded in the same way text input is encoded, and I'll say a little bit more about it. And on the output side, you want to then generate from kind of the semantic representation that are usually used to produce text to also produce audio. You start step one with a pre-trained Palm language model, and then you fine-tune it on these various kinds of speech data that exist: speech recognition, speech-to-speech translation, speech-to-text translation, machine translation, and text-to-speech generation. The key idea why this is actually become more and more feasible is this idea of audio tokens. So text models expect sequences of tokens, typically words, and speech is segmented in audio frames, which are very, very different. They're very information rich and high redundancy and a lot of noise and irrelevant content. So how can we convert speech in its raw form to something that looks a lot like text, a sequence of tokens? So the method for that is called vector quantization. So you have the intermediate states that you have in your speech recognition system. These are usually these high-dimensional vectors, these embeddings. And if you do methods like k-means clustering, you can break up all the variety of all the points that exist in that space into a few clusters. And then each cluster becomes a token. So you break it up into 1,000 clusters, and then you automatically derive from that 1,000 tokens. So there are actually two different types of tokens that are being used. One are semantic tokens that are supposed to encode phonetic information, what phonemes, what letters was you said, was it L or O, or even longer sounds. And the other information is the underlying acoustics. So this is now the voice of the speaker, the tone of the speaker, and so on. These are separate. That's very different training methods to generate these. But if you have these, you can actually do this here, what Meta just released in their Seamless for MT model, which is you first focus on the content. So you take the input in speech, generate text tokens, run it through a text translation system, and then ultimately generate speech. But then when you generate speech, you look back at the original audio sequence and get the acoustic information out. And then you basically copy that acoustic information and merge it with a now new content in the new language, and it produces speech output in exactly the voice of the speaker and in the tone of the speaker with the same kind of emotional attitude. So there is a trend now towards large speech and language models that both contain speech and text, can process speech and text. I just really imagine, what if it was be ChatGPT and you can talk to it fluently and it has the same information, and it doesn't just kind of does speech recognition and text processing and speech synthesis, but also picks up on your subtleties of how you ask a question, and like if you get slightly annoyed with the answer, and then responds to that also appropriately. So it goes beyond kind of a reduction to text, but actually takes the whole richness of the speech signal into account.
Okay, So carrying on with speech technologies, let's look now at some other things that are processing speech and processing audio in general. So one of the features that we're getting ready to release at the start of next year is audio stem separation. Now, here's a scenario for you where there's a security camera, there is a radio playing, so it's quite noisy, there's a lot of background noise, there's a male speaker, and there are two female speakers. And the two females are arguing over something, and they're speaking over top of each other, and so it's very hard for normal voice recognition to work. So what this technology is able to do is separate the noises apart. So it's able to break away the male, break away the females, each individual female, and the background noise. And these can be used independently. So it might be so that you can hear better just by removing the background noise, the radio, or it might be that you want to use them for other purposes. So what about for movie dubbing? So if we were to take a movie and we didn't have the original, could we remove the actual voices at a high enough quality that we can then go and just record only the voices, leaving the music, the soundtrack, or the other pieces? Or perhaps in a particular country, we don't have the rights to the music, but we have the rights to all the sound effects and the speakers. So what can we do there? So I'm going to show another demo now of our advanced media processing tools that deal with some of that. So I'm going to go over to media and down to, so this is our advanced media tools, and it's got things like automated creation of subtitles directly from the transcription, voice recognition straight through, laying them out in Netflix formats and various other formats. But we're going to go to audio stem separation. Now this feature's just being finished off, but you literally just drag and drop as many files as you want, and then you say, what do I want to separate? So here I can say dialogue and spoken conversation, general music and melodies, vocals and singing, instrumentals without vocals, other unspecified sound effects and things, drums, piano and keyboards, wind instruments, guitars, bass guitars, other specialist guitars. Now this takes a little while to process, so I pre-ran one earlier and loaded it. And I'm just going to play, well, let's start, I'll just move a little bit along here so we have a bit more noises. And I'm just going to play from here, and I'm going to turn the original off. So right now you can hear everything, and here we go. So let's now turn off the vocals. Now let's turn off some of the background. So now you can just hear the drums, and we'll turn the vocals back on. Okay, so Joe mentioned Knowledge Graph, and he mentioned that you know, it's important, but for another day. Well, that day is actually today. He didn't know what we were talking about. So here we have Knowledge Graph integrated, where it's able to find relationships and facts and information that can then be drawn into preparing and packaging it within the language model. So this is really good because it helps reduce hallucinations, because it's drawing on facts. It gives contextual knowledge and improved reasoning because it's giving actual data for text generation. It's a centralized source of accurate knowledge, structured knowledge for different things coming in, but ultimately the most important thing is it's a real world reference for large language models, and it can take you all the way back to the actual document that you're seeking the information from. Now here's one of the most interesting things that I like, the agents. Now agents get really smart now. Now, the agent I'm going to show you, I think, is pretty smart, but compared to some of the things we're experimenting with now that I can't present yet, but I'll be presenting early next year, this is just the beginning. So an agent can make its own prompts. It can decide how to do it. It can execute. It can create its own code. It can read, write, and push that through. Then it can decide whether it was effective or not and take remedial action. So if I was to ask a human to do this task, analyze the latest news for data privacy issues relating to public AI services such as ChatGPT and publish it on the Inissian WordPress website as a daily blog, that's probably 2 or 3 hours work every day. Now, this is an agent running in real time. I haven't sped it up or slowed it down with the exact same prompt. Now, you can see on the right-hand side, it's determined what it needs to do. Now it's analyzing and pulling articles down and searching, and it's pulling the information in. This is real time. Okay, it's found an article, it's found several articles, and it's bringing them down. Now, once it's got enough content, it's starting to say, right, I've got that. Now I'm going to compose and summarize and bring it all together. So here it is. It's completed the composure. Here's the content. Now that took less than a minute, and it's about to publish it, if I gave it the password, that directly to my website. That's the power of an agent. I did not tell it to do any of these things. The only thing I told it to do was go and get me the information and prepare it. And it did all of that in 1 minute. So we're heading towards the end now. We've just got a couple of categories left, video and images, and then we have translation, and then we're heading to the home base. So with video and images, let's hand back to Philip.
Yeah, there's a lot to be said in that space too. Yeah, we just really wanted to mention it, what is happening there. So one thing where it connects to text is basically analyzing what's in an image. The picture says 1,000 words, but you might just want to have the core information. It might be actually very different from the application, what we care about. For instance, here it says face. Maybe that's what we want, but maybe we want to know who that person is. So here's an example of a screenshot from a German television series. As you can see, the badge there says Polizei. So what could we get out of that? So here's an example of an analysis tool that we use that extracts all this information. So there's a description, and then it's kind of a breakdown of the two people. It guesses their age. It describes aspects that the man has a uniform, the woman wears a shirt, so all these kind of things. And also recognizing basically who these people are.
Right. So what one key point in there, you'll see it's got coordinates for the people's faces. So you could actually then feed those faces into image recognition for facial recognition. So suddenly, you know, actually, it's not just a man and a lady, it's Fred and Mary.
Okay, yeah, actually also one interesting thing is there's various texts in the form like Polizei, and actually with OCR connects these texts. So there's a lot of information we get out of it, and it really depends on your end user application, what you want to do with it. Okay, let me also quickly highlight like trends in machine translation. I like this chart a lot that Translated released about a year ago. So that's a translation company that in-house uses a translation tool that logs very closely how fast translators are translating, mostly of fuzzy memory matches or of machine translation. And increasingly with machine translation progressing, you see that their editing time went down quite substantially. So when they built this tool in 2015, it was over 3 seconds per word that a translator was able to translate, and now it's down to 2 seconds. 1 second is the bar of it that you just need to read the translation and say, okay, everything is fine. And if you follow this line here, you can see here's a great word, singularity, but where maybe machine translation is good enough that you don't really need to edit anything at all anymore. If this is going to happen in 2026, well, stay tuned. The other big thing is obviously, large language models took over everything else in natural language processing. How about machine translation? And yes, you can just basically ask the language model to translate, and it will translate. How good is that? Interestingly, it's not as good as dedicated systems quite yet. But it's very close. So here's a study from GPT models. There's a study from Microsoft that used actually a pre-release of the GPT 3.5 and checked how well is it at translation. And you can see here in gray is the ChatGPT, and it's outperformed by the Microsoft in-house translator and also by competitive academic systems that are really geared towards high quality and not so much about being efficient. Here's a similar study from Google, which found very similar things, where they compared, again, Google Translate against very, very competitive research systems and their farm language model, and you see a very similar pattern. Interestingly, large language models make very different errors than machine translation. So they make more meaning errors, especially errors of omission and addition. So the famous hallucination that happens with large language models, it doesn't happen so much with dedicated machine translation models, but it is better at fluency. So you see the last category, awkward, so it has less awkward or just fluent output. One interesting question is always, is this like one of these emergent behaviors that the language model suddenly figures out how to translate? And here's actually one of the most interesting papers this year, where they actually analyze like how is a language model that's really just trained on text able to translate? Well, the answer is there's a lot of translated content in the training data as well. So they have the source sentence, the target sentence in the same document, and that's what you can learn from. So there's a really interesting study that kind of breaks this down. And one point is when you really carefully remove all bilingual content, then the translation performance actually tanks quite substantially. Here's now totally off the shelf. This is actually will be actually announced later this week at the Empirical Methods for Natural Language Processing conference, where the WMT results of 2023 will release, where not only research systems are evaluated, but also the leading online systems, things like Google, Microsoft, DeepL, and also ChatGPT-4 that is prompted with 4 translation examples, and it does really well. So it's first place in Chinese English and Japanese English. Is tied with the commercial systems very closely, and only for one language, it's really clearly beaten by a commercial system. This is now just a comparison with commercial systems, not the research systems. Okay, so what else can you do with machine translation large language models? You can actually give it content. You can say, please use this particular terminology, and it can take care of that. You can also feed it with fuzzy matches and say, just fix the differences in the fuzzy matches. You can also ask it to take a fuzzy match and just generally refine it and rewrite it. So one other application is to do the fuzzy match and then do machine translation afterwards. Okay, I'm going a bit quickly because I'm running out of time. And another thing is automatic post-editing. So this is the idea that we use the machine translation system, and then after it did this work, we do the large language model that refines the translations. At this point, the large language model has a view of the entire translation and can globally look at the sentence to figure out how to improve things. What this also allows you is that the large language model then maybe can change the style of the translation. The machine translation system might just use a very bland style that is trained on in its parallel text, but maybe you want to have a particular, stylistic content. It sounds more like children books or legal documents, and then the language model can rewrite that. Here's actually the entire production cycle if you really care about high quality vetted human translations. So you have a document you translate, you first run through machine translation, then you can refine it with large language models, and then ultimately human post editor picks that up.
So this is a really important slide because this actually tells the full story, but it's missing one very last step, and that is that human post-editor's feedback is going straight back into the tools so that the very next translation is impacted and it immediately learns. So we're not talking about days or weeks of training, we're talking about almost instantaneous learning.
Yeah, I want to highlight another thing, which is that the emergence of quality estimation methods, that's still a kind of an open challenge, but it's already good enough that you can use it for this scenario. So if the machine translation is already good enough, you don't have to waste more compute time on large language models. And if the large language model refines the translation to a good enough output as deemed by a quality assessment system, you don't have to pass it to human. That definitely saves a lot of money because you don't have to even spend like a second per word for a human post editor to vet a perfect translation.
That's a key point too. So earlier, Philip showed that 1 second that you spent reading each word. If you can bypass that 1 second and not read any words and only focus on the things that the quality assessment tools say is bad, then you can process tens of thousands or hundreds of thousands of words potentially a day as a single translator. That makes a huge difference to economies of scale.
Okay, quick, just one big trend in currently machine translation systems that they operate on the document level. So often there are particular words that you can only properly translate if you have a broader context. One is pronouns, that if they translate it from a language like English into gendered languages where a table might be male or female, and then therefore it has to get the right pronoun. And also it ensures more broader consistency and also can draw in a broader context for better words and disambiguation. Okay, so here's an example. So if you have this context here, did you ever go to Paris? No, never. That is, just a regular response. Well, if the question is, did you steal my wallet? Then it might be, you might be offended. And no, never. You would say in English, no, never. But and then in French, you would actually express that with actually different words. Okay, I'll pass on to you.
Okay, so just wrapping up on the customization and adaptation, we build on top of models. So we generally don't build our own language models, things like that. We do build our own machine translation models, but our large language models, we're taking the best out there and we're giving you through Language Studio access to all of them with drag and drop and the interface you saw earlier and the ability to train them without any experience of training. So this is one of the key features that we're launching with the new Language Studio generative AI module, is it's able to learn from your data by taking a foundation model. Let's say it could be from Meta with Llama, or it could be various other Falcon or whatever, maybe the latest one this week. There may be a new one next week. You can just update the model, update and move forward with the latest and greatest. You're not left behind. You're not stalled with something that you spend a lot of money on training and it's outdated the day you finish training it.
Yeah, so one interesting twist is that, is it actually even worse to build these gigantic models? I think one of the reported numbers here says ChatGPT maybe cost $100 million. So that's a lot of money. That's even a lot of money for a company that just gets a lot of venture capital funding and just can spend the money freely and doesn't have to worry about profit at all. But even for a company like OpenAI that has this kind of money to spend, they're not going to train a new model every day or every week. They train it maybe once a year or every 1 or 2 years. So it's more important to make it efficient, to make it useful, to adapt it, and to make it actually work for your task. This is really where the action is. So let me just finish up with like a few bullet points of like what's next, what's left to solve, what are kind of the things that keep us up at night and we try to improve. This is not comprehensive, still a lot of stuff in there. So one big problem of generative AI is that there's very limited control over the output. The problems of bias. It has all the biases of the training data, all the stereotypes that are accumulated in the text. It produces toxic language, harmful content. And all this you need to have filters for that may or may not work well for various languages. Hallucinations is a big problem. There's no guarantee that the responses you get from something like ChatGPT is correct. And in my own experience, if I ask it coding questions, 80% of the time it's correct, 20% that's the wrong responses. There's also the challenge of robustness. You can't really protect it well against malicious actor. So if you think these models are all trained on web crawl data, why don't I just set a website up with corrupting training data? It's going to get crawled, it's going to be incorporated, and it's part of everybody's model. There's also continuing conversion of text, speech, and vision. So I already talked about this. So what if you do speech translation? But now you also want to do lip reading, so have more reliable processing with speech signal. What if you want to generate videos? That is actually just now happening with like new kind of software coming out where you can just not only generate text, but also video. One example, for instance, for the translation domain is you want to produce a video of the person speaking, and the mouth movement have to match now the new language. Inclusion of different modalities. For instance, if you think about medical application, you might also incorporate heart rate or sensor or any kind of sensor information. A big challenge is cost and speech. As I already mentioned, the current models are too big, too expensive to train and deploy. This will not hold up at some point, even for the big tech companies. There's a question like, why are we doing this? Why are we spending so much money? What is it actually going to pay off? And it also makes it really hard to experiment. Actually, if you look at how all these big models are trained, they're almost trained exactly the same way. Nobody has really time to experiment and then waste $50 million because the new idea didn't work out. There is, however, already a lot of progress on compression and distillation of these models, but there's much more to be done to make these really efficient and nimble to use, even at like edge devices like your phone, smartphone. Prevention of misuse is a big challenge. So you hear a lot of media discussion about cheating students and misinformation bots that, there's a new election coming up in the US, is going to be a big worry. Privacy data, as data safety concerns. You don't want to have your data come out. You want to have whatever you type in not become part of the training data. The whole copyright questions, like what can you train on, is unresolved. Ultimately, the question is, what is it all good for? So what are actually the applications that lead to novel uses and cost savings? And I believe the true benefit of all this doesn't come from replacing humans with machines that are more intelligent. There are strengths and weaknesses between humans and machines, and ultimately you have to come up with good modalities where they can collaborate and interact. This is kind of what also happened in machine translation work.
Right, and I'm just going to wrap up with the last comment as well. So while I'm doing that, if you have any questions, please drop them into the chat. Meanwhile, I just want to wrap up. The flow tools that we showed today show one very important thing, that you can enable the large language models to be incredibly powerful by feeding it relevant information. Now, that information doesn't necessarily come from the human. That comes from people actually feeding things in via other data sources. So it could be a database, it could be a query, it could be a whole range of things. So, being able to answer who is the president of the Philippines with current data was because it did a search first and then it rewrote the information it found into a one-line summary saying who it was. So those are the kinds of things that it's available to do. So, okay, let's go and have a look at some of the questions. First of all, we'll go with some of the ones that were asked ahead of the call. Okay. Will it be necessary to create some sort of rules or laws when it comes to AI use? So I think that's already happening.
Yeah, there's a lot of need for regulation. Like one is like all the couple of bullet points here about copyright, privacy, safety. If you produced some text and can you then tell nobody should use it? Can you reduce it? Can you have your name removed from all these databases? I mean, there's a very strict laws in Europe about it, but basically then outside Europe, they're not really respected.
So how about this one? This is an interesting one, slightly different, but you've actually addressed it in part, I think. When will AI replace human simultaneous interpretation?
Yeah, that's. I think I made my last bullet point is the thing. It's like, yeah, what we've seen with all these technologies, they're often good enough for certain purposes, but they're not perfect. So there's always different levels of qualities you expect. So if you really care, it's a diplomatic meeting with the presidents of China and United States, you're not going to trust the technology. There you have to be error-free and you have to have humans being accountable. So that's where that quality of the humans aren't going to be replaced.
And what do you think? Does generative AI play a primary or a secondary role in the translation process? And if not now, when? I think it's becoming the primary role.
Yeah, I didn't quite fully understand what that means.
I think the question is around, okay, how much of it's going to be left to the human?
Yeah. Yeah, I think there's all kinds of different scenarios of how humans and machines interact. So if you look at an automated chatbot that then recognizes it's completely lost and then calls a human as the one that actually can answer the customer support questions, that's important. But also just humans doing a job and using it really just as assistant tools. I mean, all these are possible too. I mean, that's how people get more productive by initiating the interaction with the AI themselves and getting the benefit out of it.
Right. So we have a fun question here. So the system seems to go beyond Language Studio and sort of becomes Knowledge Studio. Should we change the name? I think it's all about language. It's about processing language in any form. Language can be visual, it can be text, it can be audio, it can be a whole range of things. And written knowledge is a form of language. It's a form of communication. Okay, the next question, what about auto formatting things like translated PowerPoint documents and things like that? So today we do that already. We can take documents, we can even take images of documents, convert them to Microsoft Word or PowerPoint, translate them and produce the opposite on the outside while keeping the formatting. What we can't do yet is lay them out nicer. So let's say we're translating from English to French, and the French sentence is 50% longer because that's just how you say it in French than English, and it messes up pagination and things like that. Those are the kinds of things we can't do yet. Okay, I think we're out of time for today. If anyone else has any questions in the meantime, please don't hesitate to contact us. You can mail sales@omniscient.com, and the team will pass it on to me and Philip to answer you directly. So this will be recorded, or has been recorded, and it will be available sometime tomorrow on our website for replay. We thank you for joining. I know it was a long presentation today. It was a 90-minute presentation as planned. But we covered a lot of ground, and hopefully we answered a lot of your questions in the presentation itself. And finally, we wish you a great end of the year and look forward to seeing you again on our next webinar, probably in January.
Yeah.
Thank you, everyone. Bye for now.
Thanks, everybody.